All right, welcome to our third tutorial. We're getting through the quarter here. If you haven't already, go to that yell key there. I'll have it behind me too when I switch slides. No prep work this week, but just be sure to sign in on the yell key there. So today we are learning how to code, and we're going to be doing that with Game of the Year 2019, Roll a Ball, where you control a ball, you pick up collectibles, and you win the game. So before we go into that, we're going to just, like the tutorial one, we're going to give a little presentation, kind of nail some concepts down before we get into Unity. If you don't already, just have Unity Hub open on your screen, but don't open anything yet, as long as you have Unity Hub open. Yeah, as you guys know, this is common knowledge by now. Same thing next week, same day, same time, same place. We'll be building more on coding in tutorials 4 and 5, and then after that it's a little some different stuff going on, which we'll get to in the coming weeks. All right, so there's probably 3 situations that you're involved in when you enter coding, or if you've already been experienced with coding. I'm sure some of you guys haven't programmed before, and that's totally fine, because we're going to work from the ground up today. We're going to explain every line of code that we write and every line of code that's already given to us, and we're going to try to nail down the fundamentals. And coding with Unity is not learning the language that we're using, but learning how we can use the language to make games. If you have programmed before and you're a little worried about the pace, that's okay as well. We encourage you, if you've already gotten something done, mess around with some things, see if you can get things to work in a different way. If you want to go at your own pace, that's totally fine as well, if you do feel like it's going a little slow for you. But in order to accommodate everyone, we are going to be working not slowly necessarily, but very thoroughly. And if you just want to learn something new today, that's we're happy to have you as well. So, just like in the prior tutorials, we always want to hear questions. Remember, the number 1 will be a technical question, which will definitely be more prominent now with debugging and finding errors in your code. We have Henry and Evan going around to help you guys with that. And we'll also have more of those number 2 questions, especially when I explain coding concepts. So you remember those questions are, why does this work the way it does? Or can you go over that again? Or more conceptual things that I can answer from up here. So again, that's a 1 for like a one-on-one question for Henry or Evan, and a number 2 for me that I can answer up here at the board. So as per usual, we'll take pretty frequent 2 to 3 minute breaks for you guys to catch up or ask any lingering questions as well. Let's roll. So we're going to go over 3 things really quickly here. What is C#? So C# is the language that we use, and if you've used Java before, it's pretty similar. And if you used C++ before, it's honestly an easier version of C++. It doesn't have as many pointer functionality stuff that makes C++ more of an archaic language. One of the professors here calls C# C++ with seatbelts. But regardless if you do have experience with those languages or not, this is a language, an object-oriented language, as the description says, a set of instructions and rules used to produce various outputs. Used for games, obviously, with Unity. It also can be used for web, Windows applications, VR, lots of stuff. What's an IDE? So an IDE is short for Integrated Development Environment, and it's basically the environment that we're going to be coding in. So everyone should have had Visual Studio installed when they installed Unity Hub, and that will be the IDE we use today. The logo is the purple one right there. However, you can always use different ones. It's essentially the environment that you're going to be making C# code in. But yeah, obviously we suggest and recommend that you guys use Visual Studio, because that's what Unity comes installed with. Functions. Okay, so now we're going to be going into a little more of the coding concepts. Functions are blocks of code that can run on command. So, for example, saying, how do we do something, or when we call this function, some command or some line of code is going to be executed. So, like a simple line of, or a simple function. Let's say a function takes 1 number as its input and doubles that number. So, if we give a function input 3, the output will be 6. So a function may or may not take input, and then it will do something based on input or based on some other outside factors. And we'll see some of those examples when we start coding in Unity as well. If you ever want to go into documentation, which is essentially a database of the code that we use, a lot of functions and methods that you can use without having to write them yourselves. Unity has them all recorded at that website there, and we're going to be using a lot of the methods described in that website. So if you ever need to clarify them, you can go to that website there and also learn some new ones along the way. All right, and then just a brief math topic. Don't worry about this too much if it's not too clear. We're going to be dealing with vectors today. Does anyone? I'm sure you guys have done vectors. Is anyone unfamiliar with vectors? Okay, so like as you guys know, a vector, let's start with a two-dimensional vector. It has an x and a y component. So let's say like this one right here, it's going to have an x component, the horizontal direction. Let's say that's 4, and then it's going to have a y component. Let's say that's 2. So you can represent that by 4, 2. Three-dimensional vectors are the same thing, but instead of having just an x and y, you're going to have an x, y, and z component. Vector, you can see there, vector 3, x, y, and z. Just like with 2D vectors, we have the x and y component, but now we have a z component, which is a way for us to represent three-dimensional space. Here's an example of a graph representing our 3D area. We have x going in the horizontal, y going in the vertical as before, but the z is going to be going out of the screen or into the screen. This is just a way for us to visually represent that. So when we write vectors in three-dimensional form, we're going to have the 3 fields, the x, y, and z. So for example, if we just want to write a vector or represent a vector in the x direction, it would be an x of 1, and then y and z would be 0 and 0. Another example is if we want a vector going -1 in the x direction, the last one right there, and -1 in the y direction, and 0 in the z direction, we would represent that as -1, -1, 0. One more thing is a vector is a subset or a collection of numbers, and a scalar is one number exactly. So scalar could just be 2, -2, 5, any singular number. So if we multiply a scalar by a vector, we're multiplying the scalar by every element of the vector. So we're giving the vector a magnitude. We're going to be doing that later when we multiply a vector, a directional vector, by a speed. So if we multiply it by a large speed, the vector will be represented as a long vector now, and likewise, if we multiply it by a lower speed, it'll be a shorter vector. Again, this is more of a math concept more than anything, and you will see this a lot in Unity. However, if the theoretical side is a little confusing, I wouldn't worry too much about that. And I think some of the stuff we'll do in Unity will make it a little more clear. But that said, do you guys have any questions about the presentation? Cool. So we'll get right into Unity. So we have Unity Hub open, and today, like I mentioned, is all from scratch. So granted, the final product won't be as grandiose as before, but it will be all of our own. So we're going to have, whenever we open Unity Hub, the projects window should be selected. If it's not, just make sure you have projects selected on your left side of the Unity Hub window. And don't click New, but click the little arrow next to New. And you guys might have a different version. Click the most recent version you have. So I think you guys should either have 2019.2.8 or 2019.2.9. So click either of those. If you have like an older version, that's okay as well, but just pick the most recent version that you have. That'll give us this window here where we just kind of make the file. So 3D is already selected, which is good. That's what we want. New Unity project, we can change the name. Let's call it Rollable. I already made one. And then in the location, that's where we're going to save it. So if you want to click the 3 dots, you can find a place to save that and then select that folder. So once you've got that all done, we're going to create it and give it a few moments to load. There we go. All right, so this is pretty familiar. It's just like what we've seen before, but everything is blank or empty this time, and we have to work with that. The only thing that we are given is a scene. We don't have to make a new scene. We can just work with the scene. And if you guys see at the top left or on your screen, our scene is currently called sample scene. So that's a scene that we start with. So that's the only asset that we're going to begin with when we start the game. If you double click the scenes folder in the project window, we'll also see that sample scene has been saved in there as well. So it's a little different now because earlier we had a ton of stuff in the project window, but now that we're starting from scratch, just that one scene is what we're going to start with. So the first thing we're going to do, and actually let me show you guys the final game so we kind of have an idea of what we're working towards here too. So there's some things we might skip over today, but essentially if you look in the bottom left here.
Objects. We'll use this input to apply forces to the ball, making it move in our scene.
So you're moving a ball on a plane, you're collecting all these collectibles, and once you collect all of them, you've won the game. There's also a score counter at the top as well. So let's start out by making the plane or the grounds that the player's on. And again, this is new stuff. We haven't really made game objects before. We've used game objects that have been provided to us. So to make a new game object, we're going to click Game Object on the very top of our screen, and then click 3D Object, and then go down to plane. And that'll give us this kind of custom plane. It's already been, it's got its default options. Remember, you can pan by holding down, I'm in the game mode. You can pan by holding down the scroll wheel on your mouse. You can rotate around a focal point by holding down Option on Mac or Alt on Windows and then selecting a focal point and rotating around. And you can zoom in and out with the scroll wheel. So let's change it a little bit. It's pretty okay, you know. We don't want anything fancy, but let's make it a little bigger. So make sure you have plane selected in your hierarchy, and go to your inspector. In the transform component, we're going to go down to scale, and we're going to change X from 1 to 2, and Z from 1 to 2. So now that's all we made is a bigger area for us to work with. Let's also rename it just so it's a little clear what this actually is. So at the top of our inspector, this is currently called plane. So let's change that to ground. Good, so the next thing we're going to do is make the player. And if you guys saw in the game, the player is a sphere. So what we're going to do, just like before, is make a new game object. And to do that, we're going to click Game Object again at the top of our window, 3D Object, Sphere, and we got a default sphere again that's kind of been randomly positioned and sized for us. So right now, if you go to your component, or if you go to your inspector and the component transform, the position's pretty ugly. You got some weird decimal numbers for the most part, so let's just change all of those to 0. So I'm going to change the X, Y, and Z components of our position all to 0. So now we just got a better, more clear position. If we zoom in on this though, it's a little hard to tell, but the ball is actually sinking into our plane right now. And obviously we don't want that. So what we're going to do is change the position of the Y direction, because the Y direction is our vertical axis. So again, we're going to go to our inspector, and in our position variable, we're going to change Y from 0 to 0.5. So that was, you could have gone that with trial and error, but to make it in the interest of time, it's going to be 0.5, and that's because the sphere, I believe, has a radius of 0.5. All right, so what we're going to do next is do color. And again, this is a new concept. So it's kind of hard right now because the sphere is white and the plane is white, and you know, when we play the game, it's going to be a little hard to discern between those. So in Unity, colors or textures are represented by an object called materials, and we're going to create our own materials. Before we do that, we're actually going to just make our organization a little nicer. It's always something, you know, keep up with. And to do that, we're going to make a materials folder in our project window so we can have all of our materials be in that folder. So we're going to go to our project window and make sure you're in the outer folder, the assets folder. Click that on the left side. And we're going to right click anywhere in this gray area, and then click create, and then click folder. We'll get a new folder, and let's call that materials. Okay. So this is just for the sake of organization. Let's double click materials, so we're in the materials folder now. And what we're going to do is make a new material. And it's pretty easy. Just like what we did with the folder, we're going to right click anywhere in this empty space, go up to create, and then find material. So it's near the middle, sort of, beneath audio mixer, but you should find material in the create tab. So we're going to click material. That'll give us this default material. And this is going to be for the ground. We're going to change the color of the ground. So I'm just going to call it ground material. So just so we know what we're doing with this. And then after that, it's pretty easy. All we got to do now is we're not going to work with textures, but we're going to be doing colors. And to do that, we're going to go to our inspector again. And if you see this white box near the top of it, that's the current color that we have selected. But if we click the white box, we will find this color wheel. And now we can select any color that we would like our material to be. I will do blue, but feel free to do whatever color you'd like. So once you've selected your color, just click X to close out of the color window. And all you got to do now is just drag it onto our scene. So I simply drag it from the project window onto the plane. And now we've attached material to our game object. If you like, if you're ahead, you can also attach one to the ball as well, but for now I will just leave it white. So the next thing we're going to do, you know, like I said, is we're going to start going into a little coding here. Before we do that though, we want to add a rigid body to our player. And a rigid body, we've seen that before and a rigid body is essentially a component that represents the physics of our game object. So let's go ahead and do it, and then we'll kind of see how it works. So we're going to click a sphere in our hierarchy. And actually, the first thing, let's actually change this, because right now it's called sphere. At the top of our inspector, let's change the name from sphere to player, just to make that a little more clear. So once you've done that, now let's go to the very bottom and click Add Component. And like I said, we're going to be adding a rigid body. So remember, not rigid body 2D, but rigid body. And click Enter or select it, and now we got a rigid body component. And like I said, this represents the physics attributes of an object. We got mass, gravity, kinematic. We did work with this a little bit before, but now we had to add it ourselves. And now we are going to go into scripts. So we're going to click Add Component again at the bottom of our inspector. So every script we make is going to have a name attached to it, and as long as the name isn't a component, which 95% of the time it won't be, we can just type in the name that we want to call our script. So we want to call the script we're working with today Playercontroller. So capital P, it doesn't matter too much, but I'm going to do capital P, capital C, Playercontroller. And like I said, this is not a component. So whenever we type in something that's not a default component, it'll give us this new script option. So when we click on New Script and then click Create and Add, we just made a script called Playercontroller. And this will be the only script we're working with today, so just one script for the sake of this tutorial. So now we got Playercontroller Script in our inspector. If we go to our project window and click on Assets on the left side, we'll actually see that this Playercontroller Script popped up in our project window, and it's got the C# symbol on it, indicating the language. And let's make the organization a little nicer as well. So let's right-click again. We're going to make a new folder, just like with materials. Click Create, Folder, and then type in scripts. So this will be a folder with any scripts that we have in our game. Once you make the scripts folder, just drag Playercontroller into our scripts folder. So let's make the script. So we're going to double-click the scripts, and then all you got to do is double-click Playercontroller. And this should automatically open Visual Studio for you because Visual Studio was installed when you installed Unity Hub. But if anyone has issues with Visual Studio, be sure to tell us. Let's see, I won't update it. But I'll just wait till everyone's got Visual Studio up. If you open it for the first time especially, it might take a little longer than normal. All right, so I'm just going to go through line by line here, kind of what we got going on. Every script that we make in Unity will have these default lines of code. And yeah, so we're going to always start with this no matter what type of script that we're making. These first three lines up here, using system.collections, etc., that's not too much to worry about. That's just allowing us to use a lot of assets. Remember earlier I talked about the documentation provides us with a lot of methods and functions that Unity has made. That's just how we get access to them. So now we can use Unity functions by mainly using Unity Engine. Again, it's more a low-level thing, nothing to worry about for our purposes. Public class Playercontroller. You can think about this as the title. Class is a coding concept, but really this is the title of our script. And because we titled it Playercontroller, that's going to be the title that we see here. So this is just a way for us to identify our script. And then we got these two things. We got void start and void update. So the comment's pretty helpful here. Start is called before the first frame update. So what does that mean? So start is actually a function. So remember I mentioned earlier, functions are blocks of code that are called at one point, and then whatever is in the function is executed. In Unity and in many languages, functions are represented by a name and then two parentheses following them that may or may not have something in them. So if you see two closed parentheses or two parentheses with something in between the parentheses, that will indicate that this is a function. So start and update are functions. Void is saying that these functions are not going to return anything. And that's, again, nothing we need to worry about too much, but void just means that these functions don't return anything. So what is start? When is start called? Because remember, functions are called at certain points and then they're executed. Start is called before the first frame update. Now that's a little confusing. Another way to say it is start is called when our game object begins to exist. So most of the time that's going to be when we start the game. So remember, this script is attached to our player. So when the player game object begins to exist, start will be called once and only once. And that will be when we start the game. So most of the time, let's say if we have a score, if our score is going to start out at 0, we're going to say the score is 0 when we start the game. Something like that. This is called once, and for our purposes, it will be called at the beginning of our game. Update is a little different. So this says update is called once per frame, and that's kind of explains itself. Update is a function that's going to be called repeatedly. It depends on your computer, but how many frames per second that you're moving at. So this is going to be called quite a bit, depending on your frame rate. Go ahead and write what I'm writing, and then I'll explain it to you guys. And it might auto-correct it like it just did for me, and that's okay as well. So we got one more function that isn't provided for us when we begin scripting, and that is a fixed update. And like update, it's going to be called repeatedly, but instead of being called once per every frame, it's going to be called once per every time interval. And that time interval is not really well defined. It's a very small amount of time. But this is more so useful when you don't want to have issues with, if you're playing your game on a worse computer, you don't want it to lag because the frame rate's bad. Fixed update is called every millionth of a second, regardless of the frame rate of your computer. What I've found, or what Unity has said, is that fixed update is used when you want to deal with physics, because if you're playing your game on an older computer, you don't want the physics engine to be lagging because of the frame rate. And update's going to be called anywhere else when you're updating the score or updating your UI, anything that is not physics. And again, why that is not still important right now, but update will be non-physics and fixed update will be for physics. One thing I'll mention also, we've seen these little curly brackets that kind of pop up automatically. That's just indicating that whatever is between those curly brackets will be of the function. So if I just write something here, this line or anything contained between these two brackets will be executed when this function fixed update is called. Okay, so that was I know it's a lot of hand-wavy stuff, but let's write some code here and go into depth a little bit about a few more things with C#. So what I'm going to do is explain variables, and especially if you've had even a different coding language experience, some of this might be familiar. And if not, we'll go through it one at a time. I'm going to write one line of code, and just like before, we'll go over it after I've done so. Don't know why. No. All right, so what do we got here? We've got int x equals 1. So this is a textbook way to define variables in C# and many languages for that matter. And I'd say there's 5 components here we can go over. So let's start from the left. So int. Int is a data type. And there's several data types, and we'll go into some more later. And that is a form of data that we can represent. Int is short for integer. So a data of type int will be an integer like 1, -1, a whole number. X is going to be our variable name. So this is going to be what we're assigning the data to be. So if we call x, I guess I'm getting a little ahead of myself here. If we call x, it'll now be holding the variable, or holding the number 1. Equals is a little tricky, because equals in math will mean equality, and now in C# equals means assignment. So this does not mean that int x is equivalent to 1. It means that we are assigning the value 1 to x. That's very important to remember. So the equals, 1 equals sign is going to declare assignment. And then obviously 1 is our data that we are storing into x. So what is this doing? This is saying that x is an integer, and then it's giving that a value of 1. So if we called this 1.5, this would be an error, because 1.5 is not an integer. It's not a whole number. So we got to make sure, when we're declaring variables, that the data we're storing into them is of the same type. So again, because it's an int, we got to make sure that the data we're given is an integer. So if we ever call x again, if we printed x or something, it would give us 1, because 1 is now stored in x. And then one last thing is the semicolon. That is just how we end a line of code in C#. So now we've said this line of code is over. Let's move on to the next one. So let's do that. So we're going to write another line here. Word. So we got the semicolon just like before. And this time we kind of see the coloring helps, because now we see it's very similar color scheme to before. And string, just like int, is going to be a data type. And this is a new data type. String is a collection of characters. So in our case, it's a collection of letters, Andrew. However, a string can also be, oh my god, a collection of numbers, because numbers are characters. However, we wouldn't be able to add them because they're not represented as numbers, they're represented as a string. So a string is a collection of characters, and characters can be anything from the alphabet to numbers to symbols. Just like before, word is going to be our variable name that we are storing our data into. Equals declares assignment. We are assigning word to store the value Andrew. And the semicolon is the end of our line. And the one thing I should mention is strings are going to be indicated by 2 quotation marks. So whatever comes between our quotation marks will be the string that we hold. All right, 2 more here. We're going to do bool. A bool is either true or false. That's all it is. So just like before, bool is our data type. Done is our variable name. And true is the value that we are assigning to done. And a data type bool can only be true or false. So it's like an on-off switch. If you had a button in your game, you could say it's either true or false when you press it. Last one we're going to go over is float. And that is going to be a number, but this time it can be a decimal number. So just like with int, we're going to be assigning a number. So float is our data type, and float is a decimal number or a whole number. It can be any number. Y is our variable name, and 2.2 is the data we are storing into Y. But remember, like I mentioned, float can be a decimal number. However, it can also be an int. So keep that in mind. It's more expansive than int. However, it doesn't allow you to. It allows you to still use whole numbers. So that's just kind of a quick crash course. And what we're going to do now is actually write some of the code that will actually impact our game. So I'm going to write 2 lines of code, and then we will explain it to you. So make sure you are above the start function right now when you're writing this. If you're still writing, that's okay. I'll just kind of start to go into it. So the first line we got here is public float speed. So let's ignore the public for now. Float, if anyone remembers, float is a number that can be a decimal or a whole number. And then speed is going to be our variable name because it comes after our data type. So what we're saying is we have this variable speed that is going to be a decimal or non-decimal number. Public is something we haven't seen yet. And public is one more qualifier that we can use. And this is saying that we can edit this variable in Unity. So let's save the function. Whenever we want to go back to Unity, it's very important you remember to save. And if we go back to Unity and click the player game object in our hierarchy, go to your inspector and find the Playercontroller Script, we'll actually see this speed variable just popped up. So now this is more of a convenience thing than anything, but rather than having to change this variable in our script every time, we can change it from Unity. And speed is especially, we want to mess around with different speeds to see what feels right when we move our ball. So we can just change that all from Unity, and that information will be relayed to our script. So this is just more of a convenience factor than anything. This allows us to change variables in Unity rather than having to go back to the script every time. But let's go back to the script. So that's public float speed. Private rigid body RB. So RB, or let me start with rigid body actually. Rigid body is also something we haven't gone over yet, and this is going to be a data type. Every component in Unity can be a data type, so you don't have to go back, but I'll just show you. Rigid body is a component, and therefore it can be a data type. We can reference this rigid body component by declaring a variable to be of that type. RB is going to be our variable name because it follows the rigid body data type. So we're saying we have a variable RB that's going to be of type rigid body, a rigid body component in Unity. And private is the opposite of public. This just means we cannot edit in Unity. We can only edit this variable in the script. And you might ask, like, why don't we make all of them public? It's just for to keep it tidy. You don't want all your variables to be in Unity, and that can make things confusing. So if we just want it contained within the script and we only want to access it in the script, we're just going to make it private. Okay, looks like there's no questions, so let's keep going here. So the first thing we're going to do is in our void start function, we are going to add a line of code. So remember, we're in the 2 brackets in our start function. Whatever is in these brackets will be executed when start is called. So write this line of code, and then we will go over it. And yeah, you'll see a lot of these actually pop up for us. It kind of can tell you, or can figure out what you're trying to write sometimes. And if you just click enter, it'll I'll almost autocorrect it for you. But this is the line of code we got right now. And what is this doing? So RB is the variable we declared earlier, right? And that is of type rigid body. and equals denotes assignment. So we're assigning whatever is this thing into RB. So this is assigning something into a variable. But what is this? This is get component rigid body. And this is where I mentioned earlier, Unity has a lot of functions that we're going to use a lot, and this is one of them. Get component blank, and then the parentheses. And this is actually a function because, like I said before, functions are indicated by having two parentheses after them. So this is get component, and then we got this rigid body here. Now what is this saying? This is saying get the rigid body component of our game object. Let me go back to Unity. So remember you have the player selected in our hierarchy. Our script is attached to the player game object, so let's keep that in mind here. When we call get component rigid body, what we're doing is we're simply getting this component rigid body from Unity. And it's important to remember that our script is attached to the game object player, so when we call get component, we're getting the component of player. And because we said get component rigid body, we are getting the rigid body component of player. We could have said get component sphere collider and gotten that component. We could have said get component mesh renderer and gotten that component. This is just a function that allows us to get that component and store it into a variable. So now what we're going to be able to do is we're going to be able to manipulate like mass, drag, angular drag in our script without having to do that in Unity. Any questions about that? Okay, so we are going to do a few more lines and then we'll take a longer break. And what we're doing now is we're going to make our player move by key input. In our case, that will be WASD or the arrow keys on your keyboard. So make sure you are, actually let's delete the update function because we're not going to use that. So just highlight void update and you can delete that. We're not going to be using that quite yet. And we are going to be working with the fixed update function that we made earlier. So again, make sure that you are in between the two brackets of our fixed update function so we can write the code that will be executed. And go ahead and write these two lines of code, and then we'll go over it. All right. So if you're still writing, that's okay. I'll just start to go into it a little bit here. All right, so we're starting to see some familiar things here. We got float, the data type that we're going to be using, which is a number, decimal, or not. Whatever comes after our data type will be the variable name. So let's start with the first line here. Float is our data type. Move horizontal is the variable. Move horizontal will be storing a float number. And then we got something else here. We got input.getAxis horizontal. So just like with get component rigid body, this is another function that Unity has given us, and it makes our life a little easier. And this is saying we're getting our keyboard input. Horizontal represents the left and right arrow keys on our keyboard, or A and D. And this is going to give us some number input based on our key press. I believe if we press the right key, it'll give us a value of +1, and if we press the left key, it'll give us a value of -1. And I think depending on how hard you press it, it'll be a decimal number in between as well. But it's just a very compact way to give us input based on how we press our keys. Same thing with vertical. It's a float. The variable name is move vertical. And we're getting input.getAxis vertical indicates we are getting input from the up and down keys or the W and S keys. Just like before, if we click the up key, that will be a value of +1. And if we click the down key, that'll be a value of -1. So we're going to write 2 more lines here, and we'll go over it, and that will be it for now. So, and remember, the semicolons indicate we are done with a line and moving on to the next one. If you ever have errors, you'll see red lines underneath to indicate something's wrong. But yeah, Visual Studio has a lot of helpful things, and you'll notice that, like I said, whenever you're typing something, it'll try to guess what you're typing. All right, so remember we went over 3-dimensional vectors earlier, and we're going to see that right now. Vector 3 is another type. I know there's a lot of types that we're introducing, but this is a type that is saying this is a 3-dimensional vector. Movement is going to be our variable name again because it follows our data type. So movement is going to be holding a three-dimensional vector. This line followed after the equal sign is making a new vector, and that's new vector 3 indicates we are making a new three-dimensional vector. Remember, three-dimensional vectors have an x, y, and z component. Let's start with the y. You don't have to go back, but I'll go back. If we look at our screen here, the y component is actually the green arrow, as indicated by this little axis, and that's going up and down. Well, we don't want to go up and down, right? We're just moving around, sticking to the ground. We never want to fly up, going in or out of the plane. So that's going to be a value of 0. We never want to change our position in the y direction. And the f just means that this is a float. Remember, floats are decimal or non-decimal numbers. Move horizontal, remember that is our left and right input, and that is going to be the x-axis. If we go back once again to Unity, and again you don't have to, x is on the red, and that will be in this direction here. So when we move left or right, that will be translated to some movement that moves us along this x-axis. And it's the same thing with move vertical. That is going to be in our z component of the vector that we make, the three-dimensional vector. And that will be the z-axis. And if we look at our Unity window again, the z-axis is the blue arrow going this way as indicated by my mouse. So what we're doing is we're defining, based on the key press, the movement of our object by making a vector to represent that. And again, if the vector math isn't too clear, that's not as much to worry about. It's more so the actual code that we're writing and how that's relating to Unity. And then final line of code we have here is rb.addForce movement times speed. So RB, if we remember earlier, is going to store the component Rigidbody. And again, addForce is another function that Unity has provided for us. And like the name implies, we are adding a force to our Rigidbody, or in other words, we're adding a force to the physics component of our game object. So if we said the force was going up, the object would move up when we called that line of code. But in our case, we're giving the movement vector as input. So we're moving this Rigidbody, or rather the game object, based on the input of the movement vector that was based on the input of our key presses. So in a short way to say it, we took the input of our key presses, we made that into a vector that really compacted it and defined a movement or a direction of our object, and then we applied that direction to our game object to give it a direction to go. And the last thing we have here is times speed. Remember earlier we discerned between a scalar and a vector. A scalar is one number, and a vector is a collection of numbers. Movement's going to be our vector in this case, and speed is going to be our scalar. So if speed is a very large number, we're going to be moving a lot faster. And if speed is a very low number, we're going to be moving a lot slower. But regardless of speed, we're always going to be moving in the direction of movement. Speed will only impact the magnitude, or rather the length of that vector. So make sure you save it. Whenever we go back to Unity, if we don't save it, all these changes won't be updated. So save it, Controller Command S. Let's go back to Unity. Let's play the game and see if it works. So we're going to click the play button at the top center. And we cannot move. Remember, the arrow keys or the WASD keys will allow you to move. And the reason we can't move is actually because speed is 0. Remember, speed is something that we need to define in Unity. So again, we're going to go to the bottom of our inspector. We're going to find the Playercontroller Script component, and we're going to see speed is currently at 0. So obviously, we're multiplying a vector by 0. That's just going to make it 0 and not give us movement. So change that to whatever you like. I'll do, let's say 5. And let's play our game again and see if it works. And it's a little hard to tell, but yes, we are moving now. Yeah. And now the nice thing is, we don't have to go back into our script. If we want to mess around with speed, I can make it 10, I can make it 1, and we can find a speed that, really feels natural. All right, so let's get back into it. So let's take a little break from coding here. So if you go to your game mode, or if you notice when we were playing, this is not really an optimal view of our game. There is an option to make the camera move with the player, but that's a little not enough. We don't have enough time to do that right now. But what we're going to do is just make the camera at a better position. We haven't really dealt with cameras either yet, but it's pretty easy. We're going to click main camera in our hierarchy. So right now we see, it's pretty bad. It's like pretty much in line with the plane. What we're going to do is we're going to want to drag it up and then kind of make it top down. So to drag it up, pretty easy. We're just going to hold the green axis arrow and then just drag it in the Y direction. We might also want to pull it back a little bit, and to do that we're going to pull the blue arrow in the Z direction. Great. So now we can let's kind of rotate it down. So we got a nice top-down view of our game. We can do that with the tool, but I think it's a little easier just to enter numbers to do that. And to do that, we're going to go into our inspector, and in our transform component, we're going to change the rotation. I believe, is it the Z direction? It's not the Z direction. I think it's the X direction. Yes, so the X direction, let's change that from 0 to like 20. And that looks pretty good. I'm going to pull it back a little bit. Good, so like, as long as you can see the entire plane. If it's a little zoomed out, that's fine. But what we want to do is just move our camera and rotate our camera so we have a a view of the entire plane, so we can actually play the game now. So take a few moments to do that. Remember, we're moving in the scene with the 3 axes, and then we're changing the rotation in our inspector in the transform component. And you're going to want to probably change the X rotation to like 20 or 30. We could make walls. If we have time at the end, we might, but that's another thing we'll have to probably skip over, unfortunately. But again, it's pretty trivial. You just add some cubes and extend them. So that's
hard mode.
Yeah, that's the extended mode, and that's something I'm sure we could all do. It's not coding related at all. But yeah, so let's make the next thing, which will be the interactables. So in the earlier game, we saw these like spinning yellow cubes, and those were the things that the player picked up. And once we picked them all up, we won the game. So let's go ahead and add those. So to do that, we're going to let's see, create a game object, just like we did with the player and ground. So we're going to click Game Object on the top of our screen again. Click 3D Object, and then click Cube. So we're going to want our interactables to be a cube. And let's call this Pickup. So if you see the cube is the current name, let's change that to Pickup. Alright, so we're going to change the position. Just like before, we kind of have these ugly numbers in our position in the X, Y, Z fields. We're going to change those all to 0. Oops. And we're going to change the Y position to be the Y position to be 0.5, so it's not sinking into the ground. We don't want this to outweigh the player, so we're going to make it a little smaller as well. And we're going to change the scale from 111 to 0.5. 0.5, 0.5. And then just to make it look a little cooler, we're going to change the rotation from 0, 0, 0 to 45, 45, 45. So now it's kind of at an angle and it looks pretty cool. So what we're going to do next, and something we've seen but we haven't really made, and that's going to be a prefab. And I did explain prefabs last week, or we might have made one. Prefab is a game object that you're going to use multiple times. So the cube is obviously an object we're going to be having multiple times. We're going to want like 10 or 12 of them. So what we're going to do is make a prefab out of it so that we can put it in the scene as many times as we want to without having to make a new game object every time. And just like before, we're going to practice some good organization here. So in our project window, we're going to click the Assets folder. We're going to right-click anywhere in the empty space, click Create at the top, and then click Folder. We're going to call this Prefabs. Double-click Prefabs, and then drag in Pickup from the hierarchy into the project window. And now we have just made a prefab. It's all you got to do is just drag it into your project window. We'll see top right in the inspector, this is called Prefab Asset, and we have the option to open the prefab. So it'll know if you drag it from the hierarchy into the project window that we have just made a prefab. So the next thing we're going to do is start adding a bunch of these prefabs because we want a lot of them, just not the one that we have right now. So to make this a little easier for us, what we're going to do is get a top-down view of our scene because we want maybe like a circle of collectibles surrounding the player. So to get a top-down view, we're going to go to the top right of our scene view. We'll see this little widget with all the, it's like a compass with all the axes. We're going to click the Y axis that is green. And that'll give us this top-down view of our game, so it's a little easier to add the prefabs now. So the first thing we want to do is actually, we got the one that's kind of stuck in the player right now. We want to move that out, move that farther away. So let's select Pickup in the hierarchy. And we're going to see that the axis is a little jank right now. It's kind of, if we moved it, it would be going in or out of the plane. And to change that so we can move it, like based on this plane, so we're just moving left or right or up and down, we're going to change the settings from, I believe, global to local. I don't know if we've done this yet, but we're going to click local. In the top left of our screen, it's a little hard to find, but I'll circle it right here. It's next to our center button, and it's to the right of the toolbar. We're going to click local. And this will allow us to move the object locally to the axis that we have selected. So now we just simply drag it to the right, and it doesn't go in or out of the plane. It just stays in line with the plane, so it makes our life a little easier. Now all we got to do is just start dragging in a bunch of these pickups from our project window into the game, and let's so we'll make like a circle around the player. Feel free to drag in as many as you like, but all we got to do is just drag them in. So now prefabs make our life a little easier, because rather than having to make a bunch of cubes, we can just drag in the same cube as many times as we'd like. So go ahead and make like a circle around your player. It doesn't matter how many you have. So just like that. That's all it is. We're just moving in stuff from the project window into our game. And the awesome thing about prefabs is if you change the original prefab, that'll update all of the instances of our prefab. So if we change the color of our prefab, all of the cubes in our game right now would change to yellow as well, because they're that prefab. And we're going to do that. So we're going to click Pickup in our project window. And then we're going to click Open Prefab in the inspector. So whatever we change here, that will affect every instance of this object in our game. So let's change the color. And to do that, we are going to make a new material, just like before. So make sure you still have this prefab open, but in our project window, we're going to click our materials folder. So we had blue earlier. Let's make a new color. So we're going to right-click anywhere, click Create, and then click Material. Let's just call it Pickup Color, or Material, whatever one you like. So right now it's white. Let's change it to, how about yellow? So we're going to click the little color square, which is currently white in our inspector. We're going to change it to yellow by messing around with the color wheel. Once you have the color wheel selected, you can close out of that window. And if you still have your prefabs window open, all we got to do now is drag in this material onto the cube. And we've just updated our prefab. So now every instance of this prefab in the game, 10 or 12 that we dragged in earlier, should be yellow as well. So let's see if they are. So to change back to our scene mode, you'll see this little scenes button in the top left of our scene view with the little Unity logo next to it. If you click that, now all of our prefabs have updated in the game. So that's the other, like I said, that's the great thing about prefabs, is you got like the one master prefab, and then whatever you change on that will update any instances of the prefab that you have in your game. All right, we'll keep going then. So we are going to be going back to coding now. But like I mentioned, we're only working with the one script today, so you can either open the script from your scripts folder, or you should probably already have it open in your Visual Studio window. So whatever you got to do, just go back to our code that we made earlier. And what we're going to do now is make it so that we can pick up the pickups. Because if we ran into them now, basically nothing would happen. We'd probably collide with them, but we wouldn't be able to pick them up and get a score. So we're going to make a function to do that. So go ahead and type what I'm typing, and like before, we'll just kind of go over it after I do so. Make sure, just make sure this is at the bottom of your code, beneath your fixed update function. Okay. All right, so this, just like with updates and start and fixed update, is another function that's already been predetermined. Ontriggerenter is saying when our player game object enters a trigger, this block will be executed, or this function will be executed. So remember, our script is attached to the player object. So if the player object enters a trigger, Ontriggerenter will be executed. Now what's a trigger? A trigger is a collider that is defined to be a trigger. So when we're going to define later, we're going to call the pickups triggers. So if we touch the pickup, we have essentially entered a trigger. So yeah, a trigger is something, an area, or an object that if we touch, something has been triggered and this function has been called. Collider other is, so collider is the data type, again, a new data type. And that's, as the name implies, a collider or a collision box. And then other is going to be the variable name. And this is pretty nice because this gives us basically the trigger that we entered. So when we work with this later, this is going to tell us that we collided with a pickup. Other is going to be a pickup. So Ontriggerenter is a function that is called when we enter a trigger, an area of the game that is declared as a trigger. And then collider other is going to be the object that was the trigger that we came into contact with. Let's write some lines of code now. So I'll just leave it at that for now. All right, so this is something new too. So we got this if. What is if? If is pretty easy. So this is saying if whatever happens, or whatever follows the word if is true, then we're going to do whatever comes within our if statement. So after you've wrote your if statement, go ahead and add a curly bracket. So hold down Shift and click your square brackets button. This will automatically make the inner and outer brackets. And if you click Enter, now we have two brackets within our if function, or if statement. Remember I mentioned earlier, whatever is contained in these brackets will be executed, whether it's a function, or in our case now that we see an if statement. So once again, if basically we're saying if whatever follows the word if is true, we're going to call or execute whatever comes in between these two brackets. So I'll explain, we'll write one more line and then we'll go over it. So, okay. And semicolons are only needed for lines of code, not for functions or statements such as if. So anything that comes in between brackets will need the semicolons. So let's go over the first line here. If other.gameObject.compare tag pickup. So other, as I mentioned earlier, is the object that we are coming into contact with, the trigger that we enter. .gameObject is accessing the game object of other. So other.gameObject is pretty much the game object that is the trigger that we ran into. Compare tag, I think we might have done tags last week. Compare tag is going to access the tag of the game object that we collided with. And it's going to see if that tag is called pickup. So later we're going to give the pickup objects a tag called pickup, and you can make the tag name whatever you'd like. And we're saying if we collide with an object and the tag of it is pickup, we're going to do whatever comes in between our if statement. And that's the essence of the if statement. We're saying if this statement is true, we're going to do whatever comes beneath it. So again, if we come into contact with an object and the tag of it is pickup, we're going to do the lines of code that fall in between these brackets. And that line of code happens to be other.gameObject.setActiveFalse. So other.gameObject, once again, that is the game object that we come into contact with, the trigger that we enter. .setActiveFalse, again, another function that we have that we can use. And this is just not deleting the game object necessarily, but it's just making the game object invisible. SetActiveTrue, likewise, would bring the game object back. But because we're running into the pickups and we want them to disappear, we're going to call this function setActiveFalse to make it disappear and cease to exist in our game. So let's save it and go back to Unity. There's one more thing we got to do. Remember I mentioned earlier, we want the pickups to be tagged, we want it to be tagged pickup. So just like with the color, we can change the tag of the prefab so that all of the versions of our pickup in the game will also be tagged. So let's go to the prefabs folder in our project window. Click on pickup. And we're going to click open prefab just like before in the inspector. So we got at the very top, if we'll see right below the name pickup, we got tag, and then in the scroll wheel we got untagged. So there is no tag attached to this game object. So you can click that, you'll actually see a lot of tags. There's some default tags we can use. However, we want to make the tag. Does anyone remember what the name was? What was the name of our tag in our code? So it was pickup. So we're going to be adding a tag called pickup. So if we go down and click add tag, this will allow us to make a tag with our own name. So we can make a tag, call a tag, whatever we'd like. But as I mentioned, we want this tag in particular to be called pickup because that's the name that we reference in our code. So we got this list is empty, and if you see the little plus symbol, we can click plus, and now we can just type the name of the tag, so pickup, and it's important that you write it correctly. So remember, pickup with a space between, and P and U are both capitalized. If there's a typo, our code's not going to be able to recognize that, and we'll get an error. Once you've done that, click Save, and click the Pickup Prefab one more time in our project window. We're going to click Open Prefab in the inspector again. Oh, wait a second, it's still untagged, and that's because we actually just made a tag, we didn't assign the tag. But now if we click Untagged, we'll see Pickup has just appeared. We made the tag, and now it's in our tag scroll bar. So now we can click Pickup, and now we have said that the Pickup game object is tagged Pickup. So if we collide with a Pickup game object, we will recognize its tag as Pickup, and hopefully when we it'll disappear. Sorry, there's one more thing to do that I almost forgot. If we click Pickup again in our project window and click Open Prefab, you'll notice earlier that I said that this is a trigger, and when we come into contact with it, it is recognized as a trigger. And to make that happen, all we got to do in our box collider component is select the checkbox next to is trigger. That's all it is. So we're just saying this is a trigger now. If we come into contact with it, we have come into contact with a trigger, and the block of code we wrote earlier will be called. So let's play the game and see if it works. So remember, when we come into contact with the box, it should disappear. And let's see if that works. And it looks like it does. Okay, so we'll see how far we get, but the next thing we're going to do, and if you haven't already, make sure you're in your scene view by clicking the scenes button on the top left of our scene window. We are going to add a score counter now, and we saw that in the example game as well. So we're going to add a little text in the top left of our screen that updates based on how many pickups we pick up. So score starts with 0, and then when we pick up 10, that's will be when we have won our game. So again, this is a new concept. I know we're throwing a lot at you guys, but we are going to make UI, and UI is short for user interface, and text is a form of UI because it's something that we see on the screen that provides information like a menu or a pause menu. Those are other examples of UI. To make UI, we are going to go to game object again at the top of our screen. We are making a new game object. Go to UI, and then click text. So now we got text, and we got the canvas and event system, which don't worry about that too much, but all we need to worry about is we got this text that appeared in our hierarchy. We'll go to our inspector, and we got a ton of stuff that we can change over here. So the first thing, let's change the name of text so we know what it is. Let's change text to count text. And I've found that editing UI is a lot easier to do in the game mode. So if you switch to your game view, you hopefully should see your text in the center. It's probably going to be very small, very hard to see. Does everyone see their text somewhere? Remember, we're in the game mode too. Okay, so if you see it good, we're going to kind of make it a little more obvious. Remember, we're going to want this at the top left. So the first thing I'm going to do is change the color from black to white to make it stand out a little more. And in our inspector, we should find the color field near the bottom is currently black, this black bar. If we click that, we'll get our color window again, and we can change that to white, or any color that you like. So once you found your color, close out of the color window, and our text has updated with that. I'm going to change the size. We definitely need this to be bigger. And to do that, you can find the font size field. So right now it's at 14. I'm going to change that to 50. And we'll see that the text probably disappeared. And that's a little annoying, and that's just because our text box is also something that's defined, and our text box is too small to accommodate large text. Our text box is at the top of our inspector, and that's going to be the width and height fields. If you change width to like 1,000 and height to 1,000, we're just making a huge text box now. And actually 100 might be a better way to go. Well, you'll have to mess around with it, but basically you want it to be big enough to accommodate the size of your text. My font size is 50, and my width is 1,000, and my height is 100. So I just made a text box big enough to hold the new font size. It's a little annoying, but you always want your text box to be big enough to accommodate a larger font size. What we can do next is change the position. We want it to be in the top left. So right above the width and the height, we see pause X and pause Y. You can either enter the number, or you can just drag it by holding down the text of pause X or pause Y. And just drag that and kind of fine tune your position based on that. So again, I'm going to put it in the top left. So I'm going to drag the X and Y until I get my text in the top left. Ooh, it's hard to see. So I'll make sure I can read it too. So somewhere like there is fine, but again, if you want to put it somewhere else, that's okay as well. But do remember that this will be displayed at all times. So it shouldn't be distracting the game. So you shouldn't really have it over the plane or the player. All right, so once we got text, let's do, I think we'll do one final round of scripting here. And again, we are in the same script, so open Visual Studio, and we should have the Playercontroller Script. So what do we got to do here? We need to make some variable that's going to store our score, right? Because we're going to want to update that based on if we collide with the pickup object. So I'm going to call this variable count. And just like what we did with speed and RB, I'm going to write it right here. So write this line of code right beneath private rigidbody RB at the top of this class. So I'm going to write private int count. So again, this is a variable called count. It's going to be an integer because count is never going to be a decimal number. It's 0, 1, 2, 3, etc. And it's private because we don't need to modify this in Unity. There's no reason for us to change the count. It'll always start at 0. So next thing we're going to do in our start function, go ahead and write down count equals 0. Just like that. This is pretty easy. I mean, when we start the game, the count is 0. We haven't picked up anything. So all we're saying is when we start the game, give count the value of 0. Because, no 0 pickups have been picked up at this point. Then we're going to scroll down a little bit and go to Ontriggerenter. Go ahead and write this line and make sure it is between the two brackets of our if statement. So what did I do here? So this is where the assignment definitely comes into play, because if this was a math statement, it obviously wouldn't make sense, because count does not equal count plus 1. But as we've seen, one equal sign is assignment. And this is saying what we're doing is we're giving count the value of the previous value of count plus 1. So if count was currently 2, let's say we've picked up 2 objects at this point, and we just picked up a new one. What we're doing here is we're saying the new value of count is equal to the previous value of count plus 1. So in our case, the new value of count would be equal to 2 plus 1, so therefore the new value of count is equal to 3. So this is kind of a way to iterate and change the value of a variable based on the previous value of that variable. Any questions about that? Yeah.
Can you Java count plus and count plus equals 1?
Yeah, you can. Yeah. So yeah, I'll actually show it. You can also do count plus plus, and that's just another way to write it. That's what I'll usually write, just for the purposes of explanation. I wrote the first one, but that's a very shorthand way to write the same thing as this statement right here. All right, so we've made a count variable, but we haven't really updated the text, and that's what we want to do. And to do that, we're going to do a few, not trivial, but just more so stuff you don't need to worry about too much. And we're going to, at the very top of our code, beneath using Unity Engine, we're going to type in using Unity Engine dot capital U, capital I. And this is like using Unity Engine. It's giving us a lot of functions of UI this time. I don't know why you have to import that one specifically, but for some reason we need to import that so we can have UI functions in our code now. And now what we're going to do is we're going to find a way to reference the text in our Unity into the code. And to do that, we're going to first create a public variable. So beneath private int count, go ahead and write this line. So what do we got? We got count text is the variable name. Text is our data type, and obviously, that's a text, a UI text. And then public indicates that we can change this variable in Unity. So later what we're going to do is we're actually going to drag the text variable in Unity, that blank new text that we have, into this field. So what we're doing is we're updating something in Unity by making it a public variable. But for now, let's just assume that count text is the text that we have on the top left of our screen, or wherever you put it in your game. So when we start, we want our count to be count colon 0, right? So go ahead and write this line of code beneath count equals 0. All right, so we got count text.text. Now, what is that? That seems a little redundant, but what we're doing is count text, remember, is the text asset, and we're accessing the text field of that. And why does that seem redundant? Well, you can also access like the fonts. You could do count text.font or count text.size. .text indicates that we're getting, the words or characters that we display on screen. Again, one equal sign, we are assigning whatever comes after it to this text variable. And we're assigning, first of all, this quotation count colon. Remember I mentioned earlier, anything surrounded by quotation marks is a string. And text is always going to be a string because it's a collection of characters. Count colon is something we want to be on our screen. It can either be count colon 1, count colon 2. It's going to be how we represent our count on our screen when we play the game. But we can't just have count colon blank. We need to have the number attached to it. And that's what we're doing here. We're doing count.toString. So let's think about this for a second. Count, that's currently 0. And that's good because the count, when we start the game, remember this is being called in our start function, the count will be equal to 0. So what we want to display is count colon space 0. However, count itself is a int variable, and we can't combine a string with an int. So toString is a function that converts an int into a string for us. So now what we've done is say count.toString is now the string 1 and not the int 1. And when you add two strings together, that just jams them together. So what we got by adding these two statements is count colon space 0. Likewise, what we can do is actually copy this line of code. So if you drag over it and then Control or Command Z or C, we're going to go down to the Ontriggerenter function, and below other.gameObject.setActiveFalse, we're going to paste this line of code. So we're doing the same thing here now, but remember the count variable is updating, so we have to reflect that in the text. So if the count variable has changed to 2, now we need to display count colon 2 rather than count colon 1. And to do that, we're just going to change the text every time we run into a pickup object. And because we've called it through the variable count, if count is now, let's say, 4, when we call this line of code, we're going to add count colon space to the string 4. So we're calling this line every time we come into a pickup so that it can update the count variable in our text. So let's save that and go back to Unity. And one more thing we have to do before this will work is, remember earlier I mentioned we have to reference the text in our Unity so that our script can read it. Remember, our script is still attached to the player, so click the player game object in our hierarchy. Scroll down to Playercontroller Script, and now we got a new variable here. We got count text, and then we got this none text, and that's just saying nothing is in this field right now. If we actually ran the game, we'd get an error, so we'd get this null reference. Nothing is being referenced in this field. All we got to do is drag in count text from our hierarchy into count text in our inspector. Now whenever we reference, whenever we reference text in our script, we know what we're referencing. We're referencing the text asset that we made in Unity. So we're finding a way basically to communicate between Unity and our C# language. So let's give it a shot. Let's play the game. And good, count colon 0 when we pick something up. Count 1, count 2 and 3, and so on. So yeah, just like before, we can make a build of this if we'd like. So if we go to File on the top left, go down to Build Settings. This time we have to add open scenes, so click the Add Open Scenes button. Sample scene's open, so we're adding that, and we only have one scene, so we only need to do that once. And just like before, we can click Build at the bottom right and make an application of the game if we ever want to, play it without having to open Unity or share it with people. That's just an easy way for us to export a copy of the game that's easy to use and easy to play. And this time it'll be a lot faster because we don't have as many assets as we did with tutorials 1 and 2. So just like before, if you guys ever want to go back to the tutorial we did today, this is in Unity Hub in our Learn tab. If we scroll down to Rollerball, It's not going to have the download because there's nothing to download. We're going to click View Tutorials. This is going to be, this time it's a video format. But yeah, this will have all the instructions that we went over today. I did have to skip a few things if you guys want to go back and do those, and that was making a script for the camera to move with the player, which is pretty cool. Making walls, which that's pretty easy. It's just adding game objects and moving the position and changing the size. And the last thing, as I mentioned earlier, was changing win text, which is also not too bad given what we did with the count text, but that's saying if we collected, this many balls, or if our count variable is greater than or equal to, let's say we had 10. If it was greater than or equal to 10, we would display this text that says you win. So yeah, we pretty much got through all of it, but like I said, if you guys want to go back through stuff we did, or go over stuff that we didn't have time to get to, this is the source to go to. We'll also put it in Discord as well.
Check out the recording, that's what we were.
Yeah, a 95% chance it fails. But yeah, that's all I have for today. This is my last tutorial, so I just want to thank everyone for being a good audience. Sebastian will be doing next week, and that'll be more coding, so we're going to just be building on that in weeks 4 and 5. Might as well go through it now. Week 6 is going to be Cinemachine, which will be making cutscenes, which is pretty cool. Week 7 will be an intro to Git, which is a collaborative tool that people use to code together. And then week 8 will be a fun lecture about game design and storytelling and stuff like that. I just want to thank everyone for coming out. Really happy to see you guys coming out every week, and thanks for coming today. I hope to see you guys next week.